In this demonstration, we develop IntentRec for Maps system, a system to recognize users' intentions in interactive maps for real-world navigation. Our system IntentRec for Maps uses the Google Maps platform as the real-world interactive map, and it employs a very effective recognition approach for recognizing users' intentions in real time. In this video, we showcase IntentRec for Maps by explaining its main components, as well as showing some examples of its functionalities. Our system is composed of two main components. The interactive map platform component, the component that relies on the Google Maps platform and its APIs to display the interactive map for real-time intention recognition. The real-time intention recognition component, namely, an intention recognizer. The component that performs the real-time recognition process according to a set of input information and provides a probability distribution reflecting the most and least likely intentions in response to received observations. The interactive map platform is used as the environment that is represented by the road network with location points of interest, and the state space consists of the geographical locations on the map. A location point is represented using latitude and longitude coordinates in a map. Actions are represented by moving from one location point to another, following a specific route or path according to a transportation mode, such as driving or walking. We define a route as a sequence of latitude and longitude coordinates that achieves a specific location point from an initial location point. We define an intention recognition problem in real-world navigation maps as a tuple. M is the real-world map environment, represented by a road network with location points as latitude and longitude. Initloc represents the initial location point as latitude and longitude. I is a set of possible intended location points that an observed user may aim to achieve. An OBS is a sequence of observations that the system observes incrementally. An ideal solution for this problem is recognizing the correct intended location point LOC in I which is unknown from the recognition system's perspective that an observed user aims to achieve for every observation point O in the observation sequence OBS. We use a JSON file to enter the input data used for the system. We use init to set our starting location. In this case, it is Kensington Palace, London. Intent location is the destination that is intended for our agent. Intentions is an array that contains a set of destinations, including our intended destination. We use mirroring as the approach for our recognition technique from Veid's 2016 paper. Mirroring is the idea that humans infer other people's intentions by mirroring their observed behavior with some optimal expected behavior. We compute an ideal route from the initial location to all the location points in the set of intentions. We then compute the observation route, which is computed from the initial location whilst complying with the observation points and reaching the possible intentions. For each of the possible intentions, we compare its ideal route for its observation route and compute a score from it, which represents how compliant the observations are to the route. We compute the similarity distance comparison using the Haversine formula shown on the slide. We use Google Maps for the baseline path planner and also for the observed person using the real-world navigation system. We also use a different navigation system called Mapbox as an alternative for the recognition process, which makes the process more difficult. And a LLM, such as ChatGPT-4, as a path planner to see how reliable they are when used as a solver for the reasoning planning process. It is worth noting LLMs perform the worst in terms of accuracy, which is expected, as they are not explicitly designed for this. Let's take a closer look at how IntentRec for Maps works in real time using a practical example. Imagine we are tracking a car navigating the bustling streets of London. Starting from the King's Cross station and heading towards to Waterloo station, marked by the green icon on our map. There are 5 possible goals across the city, and the task is to observe how well the system recognizes the car's intentions along the way. An observation number variable can be changed to evaluate the system's performance at different stages of the journey. In this demonstration, we'll be comparing the performance of 2 solvers, Mapbox and OpenAI, the large language model, across 2 different observation settings. Firstly, let's evaluate the performance of Mapbox with 10 observations to build a benchmark. Initially, the intentions towards each goal may appear similar, but the system swiftly recognizes car's true intention after passing the intersection with the yellow goal. Upon reducing the observations to 5, we still observe correct recognition results. However, there's a noticeable drop in performance, evidenced by 3 identical intentions detected. Now, let's observe the performance of the large language model with 10 observations. It's worth noting that since the routes are generated by the LLM, results may vary with each run. Surprisingly, this time, OpenAI performs even better than Mapbox, both with 10 and 5 observations. Yet, as expected, there's still a drop in performance with only 5 observations. Next, let's delve into a more challenging example for the system. We're still starting from King's Cross station, but this time the intent goal is Victoria station, with the green icon. The tricky part here is the presence of another potential goal marked by the purple icon, Buckingham Palace, which is very close to the real goal. By using the Mapbox as the solver, the system struggles to recognize the intention, achieving a recognition rate of only 39%, just 2% higher than the intention towards Buckingham Palace. As for the performance of the large language model, in the first run, OpenAI failed to recognize the correct goal and instead identified Buckingham Palace as the intent goal. In the second run, we increased the observations to 20 to assess any improvements. Finally, OpenAI succeeds in intent recognition, surpassing the close potential goal by only 0.3%. Real-time intention recognition could enable interactive navigation centralized systems to adapt dynamically, adjusting the location points to be achieved in real time in response to changing users' intentions. Thank you for watching.